The recording and I will start sharing my presentation. Okay. Now today we are going to see numerical based on the boundary conditions. बाउंड्री कंडीशंस के लिए मैंने बताया था कि आपको पूरा टेबल याद रखने की बिल्कुल ज़रूरत नहीं है. व्हाट यू रिमेंबर ओनली टू कंडीशंस फ्रॉम एवरी सेट. ओके, सिर्फ इतनी कंडीशंस आपको ध्यान में रखनी है. रेस्ट ऑफ द कंडीशन यू कैन डेफिनेटली derive at that moment of time on your own. So make sure that you do have this table in your notebook. We will require this table while solving the numerical. Okay. So let us go with the first numerical. Let us try to read it. Given electric field. Okay. E1 दिया हुआ है. So do remember that any vector. So let us talk about E vector. It can be expressed as addition of its normal component plus addition with a tangential component. Okay. So E1 bar is equal to 2ax cap minus 3ay cap plus 5az cap at the charge free dielectric medium. मतलब क्या कहा है आपको कि भाई dielectric medium है. Calculate D2 and angles theta 1 and theta 2. You are given with this diagram. Okay. आपको ये diagram दी हुई है. Sometimes you need to draw the diagram and sometimes you need to um, you will have the diagram in your question itself. Okay. So looking at the diagram, this is boundary of the two medium, separating medium 1 and medium 2, where for medium 1 epsilon r is equal to 2 and for medium 2 epsilon r2 is equal to 5. So in medium 2 we will have all the quantities having suffix 2 and in medium 1 we will have all the quantities having suffix 1. Okay. So um, we have E1 vector indicated in the diagram. Diagram is given. E2 vector is also indicated in the diagram. Okay. Now E1 vector can be break into En1 and Et1. Okay, but since this is a dielectric medium, we know that Et and Dt are equal to 0. Not really 0, that was a condition of dielectric conductor, but for dielectric medium, we do have Et1 is equal to Et2. We will use this one. Okay, the diagram is given. Do remember that we do have theta 1 angles and theta 2 angle indicated as in the diagram. We will utilize all the information given into the numerical. Okay, इतना diagram ध्यान से देखना है आप लोगों ने. And now we are going to analyze. Okay, what is given with us? E1 bar is equal to 2ax cap minus 3ay cap minus plus 5az cap. Okay, so I can say that. Okay, fine. Looking at the diagram, we have En, normal component of vector E1 along z-axis. Very important. So therefore, this implies that En1 is equal to 5az. क्यों? क्योंकि En vector is along the z-axis. Therefore, we can say that Et1 is equal to 2ax cap minus 3ay cap. Okay. So according to boundary condition, what we have? Et1 sorry is equal to Et2. So I can say that okay, Et1 is equal to Et2, therefore Et2 is equal to 2ax cap minus 3ay cap. Our target is to get D2. Okay, we will get D2 if and only if we get DT2 and DN2. We are trying to get those values. So we do have ET2. So we can say that this implies that if at all we want to get DT2, that means epsilon 0, epsilon R2, because we are talking about the second medium. Okay, second medium. Therefore we have use epsilon r2 and et2 bar. So therefore dt2 epsilon r2 is 5. So we will write down 5 epsilon 0 and et2 is 2ax cap minus 3ay cap. Okay, we got dt2. Then we have something related to the normal component now. We know, let me go back to your diagram. We know dn1 is equal to dn2. Okay, and similarly we can have dn1 value or dn2 value from this expression. Okay, how to get it? Let us see. So we know that now dn2 is nothing but epsilon 0 epsilon r2 en2. Okay, now how to get en2? If you remember over here, en1 and en2 are related with each other like this. So we will write down since en1 upon en2 is equal to, okay, what we had in the formula epsilon 2 upon epsilon 1. So we will write down epsilon r2 upon epsilon r1, that gives us en2 as, okay, en2 as epsilon r1 upon epsilon r2 en1, okay, and epsilon r1 is 2 upon 5 and en1 is, here it is, okay, en1 is 5 az cap. Okay, so we will use this one en2 in this expression. Therefore we can say that dn2 is epsilon 0, epsilon r2 over here is 5 and en2 is, okay, en2 is 2 upon 5 into 5 az cap. Okay, so we can write down, okay, dn2 is nothing but 5 gets cancelled out, and I can say that I will keep right now for moment 2 epsilon 0 5 az cap as it is. Otherwise we can also write down epsilon 0 into 10 az cap. Okay, no problem. So we now have dn2 and dt2. So we can definitely write down d2 bar is equal to what we have. D2 bar is equal to dn2 plus dt2. dn2 we have with us 2 epsilon 0 5 az cap plus we have dt2 as well here. Okay, 5 epsilon 0 2 ax cap minus 3 ay cap. So now we can have everything now with us as taking out epsilon 0 outside, and we will have 10, sorry, I will write down in a sequence ax cap ay cap in this way. So okay, so we have 10 ax cap minus 15 ay cap plus 10 az cap. Okay, we will have all these things with us. Now we need to have first target is achieved. What is the expression of d2? Now we want to have theta 1 and theta 2. How to get? I will do a rough work over here first, and we will go on solving the numerical next. Okay. If we think about theta, let us say theta 2. Okay, theta 2 की अगर बात करते हैं, so we can say that okay, sine of theta 2 is nothing but magnitude of en2 upon magnitude of e2. Okay, sine का formula opposite side upon hypotenuse. Okay. Similarly we can say that sine of थीटा वन इज इक्वल टू, देखो यहाँ पे अभी en1 है, so according to law of parallelogram we will have this one also as en1. Okay, so sine of theta 1 is equal to en1 bar upon magnitude of e1 bar. Okay, now our target is to get the magnitudes of everything. Okay, so about E1, about sine theta 1. Okay, about sine theta 1, we have E1, so we can have the magnitude of E1. We have En1. Okay, we have En1, so we can have magnitude of En1. So theta 1 is easy. About sine theta 2. Okay, we have En2. We have En2, so we can have magnitude of En2. Do we have E2? Yes, we have E2 because we have ET2 as well as we have EN2. So here I will write down as a rough work, but you can write down it as in a fair way. So E2 is equal to ET2 plus EN2, and looking at into our formulae. So we do have ET2, that is 2ax cap. Sorry, one moment please. Okay, so we do have 82. Okay, 82 where we were having, okay, 82 was 2ax cap minus 3ay cap, and en2, this was en2. Okay, this is en2, and that is, I will say, 2az cap. Okay, so we do have this one, we do have this one, we do have this one and this one. So simple trigonometry will give you angle theta 1 and theta 2. Have you understood this one? I want a feedback.
Yes, sir.
Okay, thank you, Piyusha.
Yes, sir.
Pratiksha, thank
Yes,
you.
sir.
Hmm?
Yes, sir.
Okay, Samruddhi. So, do I need to do calculations for theta 1 and theta 2, or you will do on your own so that we can go to next numerical? Shall I do it or no? चलो ठीक है, कर लेते हैं, कर लेते हैं, ठीक है. So we do have sine of theta 1 is equal to en1 उसका मैग्नीट्यूड अपॉन e1 का मैग्नीट्यूड. सो en1 was कितना था रे, 5az था ना, 5az. therefore magnitude of en1 bar is equal to 5. e1 बार जो दिया हुआ था वो था 2ax कैप, कितना था, 2x कैप माइनस 3y माइनस 3ay plus 5az. Therefore, magnitude of E1 bar is equal to 4 plus 9 plus 25, and this will be somewhere under root 4 plus 9 plus 25. This is 6.164. Okay. So therefore, sine of theta 1 is equal to 5 upon 6.164. देखो ये जो रेशियो है ना हमेशा 1 से कम आना चाहिए. अगर ये 1 से ज्यादा आ रहा है मतलब न्यूमरेटर इज गेटिंग बिगर देन द डिनोमिनेटर मींस वी हैव डन समथिंग रॉन्ग, क्योंकि मैक्सिमम वैल्यू ऑफ साइन ऑफ एनी एंगल इज 1, नॉट मोर देन दैट. So this implies that theta 1 is equal to sine inverse of 5 upon 6.164. This implies that theta 1 is equal to sine inverse of 5 upon 6.164. 54.21 degree. Okay, we are dealing with degree. Sine of theta 2 is equal to what we have, en 2 bar उसका magnitude upon e2 bar का magnitude. What we have, en2 expression was 2az cap. Okay, en2 expression was 2az cap, therefore magnitude of en2 is equal to 2. Expression for e2 bar. Okay, e2 bar we want to have e2 bar, et2 bar 2ax. Okay, 2ax cap minus 3ay cap plus 2az cap. Therefore magnitude of e2 bar is equal to under root 4 plus 9 plus 4, 4 plus 9 plus 4 is 4.123. Therefore sine of theta 2 is equal to 2 upon 4.123. This implies that theta 2 is equal to sine inverse of 2 upon 4.123. This gives us theta 2 is equal to shift sine inverse of 2 upon 4.123, 29.02 degree. Okay, isn't it straightforward? Have you understood everything?
Yes, sir.
Yes, sir.
Okay, so you have to solve all numerical. Okay, all numerical based on boundary condition with this approach only, nothing different, nothing different. Okay, sometimes you will have to use a more set of formulae. Okay, that's it. जैसे यहाँ पे ट्रिग्नोमेट्री लगा लिया या फिर यू विल हैव सम एनर्जी का फार्मूला वगैरह वगैरह. सो you these are very important numerical which are very easy and sure short numerical from the exam point of view, and just use the set of formulae, apply the trigonometry and you will have everything. ओके, कहीं पे मिस्टेक होने की मतलब बात ही नहीं है, बिकॉज न्यूमेरिकल सॉल्यूशन इज क्वाइट इजी एंड स्ट्रेट फॉरवर्ड. ओके, दिस वाज अ न्यूमेरिकल बेस्ड फॉर डाइलेक्ट्रिक मीडियम. ओके, सो इफ यू हैव काइंड ऑफ एयर, अगर यहाँ पे डाइलेक्ट्रिक मीडियम 1 या डाइलेक्ट्रिक मीडियम 2 नहीं होता एंड वी हैड this kind of boundary, okay, this kind of boundary होती थी, तो instead of this epsilon r1 we would have used epsilon r0 only, that much only difference, उतना ही difference. The rest of the procedure will remain same and values will get changed. सिर्फ यहाँ पे मैं न्यूमेरिकल में चेंज कर दूं अगर at the charge free air dash dielectric boundary, बस इतना चेंज कर दिया कि डिफरेंट न्यूमेरिकल बन गया, बस दैट्स इट. बिकॉज यहाँ पे एयर और डायलेक्ट्रिक में we do have different set of formulae. Okay, we do have different numerical as well. We will give this one as homework, and we will go with numerical based on magnetic medium. Okay, magnetic medium boundary. And since we are dealing with magnetic medium, we will have permeability in picture now. Okay, so let us read the numerical. The region x greater than 0. Okay, x की बात हो रही है, अभी पिछले न्यूमेरिकल में क्या था, z की बात थी. Okay, fine. The region x less than 0 is medium 1, and since diagram is not given, we will try to draw it. Okay, your boundary is defined in terms of x, so we will draw our axis. Okay, and this axis we assume as x-axis. We have a boundary x less than 0, so this becomes our medium 1, and automatically this becomes our medium 2. Medium 1 has mu r1 as 4.5, and medium 2 has mu r2 as a 6. Okay. We have h1. Okay, we have h1 that will be in medium 1. Okay, we have an expression for h1, 4ax cap plus 3ay cap minus 6az cap. Okay, so looking at the diagram, definitely we can say that okay, this is h and 1, and rest of the two components will give us h t1. Okay, ax cap, x axis is perpendicular to the boundary. Okay, we need to find h2 and angle made by h2. Okay, h2 को draw करते हैं. Okay, we do have h2 and angle made by h2 with vertical axis. Which is the vertical axis? This is. So आपको ये वाला angle find करना है. Okay, let us break our h1 into its normal component. Okay, this will be hn1 bar, and h2 will have this vector as its normal component hn2 bar. Okay, तो ये डायग्राम हमने बना ली from the given description. Okay, एंगल मेड बाय h2 विद द वर्टिकल एक्सिस, तो ये बोला है. अगर यहाँ पे एंगल मेड बाय h2 विद द हॉरिजॉन्टल एक्सिस होता था तो वी वुड हैव गॉन फॉर दिस एंगल. ओके, लेकिन वर्टिकल एक्सिस बोला है तो वी विल गो विथ दैट थीटा. Okay. So probably you might have understood how we can draw the diagram by looking at the given numerical data. Sorry. So given is h1 bar is equal to 6ax cap plus 3ay cap minus 6az cap. So this will give us hn1 bar as 4ax cap and ht1 bar as 3ay cap minus 6az cap. Okay, now since we are looking at boundary conditions of magnetic medium, okay, we have one formula which talks about the normal components. जो भी इक्वल वाला है ना उसको पहले ले लेते हैं. Okay, bn1 is equal to bn2. What we have hn1, so we can say that since bn1 is equal to bn2, we can say that mu0 mu r1 hn1 is equal to mu0 mu r2 hn2. Okay, fair enough by putting the definition of b into the formula. So we can have fine, this will give us, our target is to get h2, so therefore our target is to get two components of h2. So here we can have hn2 represented as mu0 gets cancelled out, so we will have mu r1 upon mu r2 hn1. So mu r1 is 4.5 and mu r2 is 6 and hn1 is 4ax cap. ठीक है, इतना मिल गया. Now we want to go with क्या कहते हैं tangential components. In formula we have, if you remember, ht1 ht2 is equal to k. Okay, and since the numerical do not talk about this k, we can say that assuming linear current density to be 0, we have ht1 is equal to ht2. I repeat the sentences. Since numerical do not talk about k, we are assuming that linear current density, this k was linear current density as 0. Therefore, ht1 is equal to ht2, and since we have ht1, we can say that ht2 is equal to 3ay cap minus 6 az cap. Therefore, now we can say that, okay, H2 is equal to Hn2 plus E, oh, E nahi, Ht2. Okay, Hn2 क्या है? 4.5 upon 6 into 4 ax cap, और Ht2 क्या है? Is 3ay cap minus 6 az cap. Now about the AX cap, I will do the calculation. 4.5 into 4 divided by 6 is equal to 3. Okay. So what I will write down over here, instead of everything, I will write it as 3. 3AX cap. Okay. So we do have H2. First target achieved. Let us go with the second target. Okay. Now we want to have this theta, the theta of H2 with vertical axis. Okay. Now we can break H2 into its normal component and its tangential component. Okay. This is HT2 bar. Okay. Now we can take this vector as a parallel vector over here with same direction and equal magnitude. This will also HT2. So we can definitely write down sine of theta is equal to, let us not go for sine of theta because we don't have we do have hypotenuse. Okay, we do have hypotenuse. So sine of theta is equal to ht2 bar upon magnitude of ht2 bar upon magnitude of h2. Okay, so we do have H2, therefore we will have magnitude of H2 bar as 9 plus 9 plus 36. Okay, so we will have under root 9 plus 9 plus 36. This will give us 7.348, and we want HT2 magnitude. Therefore, over here HT2 bar uska magnitude is 9 plus 36. This will give us as 6.708. So we can say that, okay, so therefore theta is equal to sine inverse of HT2 magnitude is 6.708 and H2 magnitude is 7.348. So this will in turn give us sine inverse of 6.708 divided by 7.348. This will give us theta is equal to 65.909. Okay. Tada! Okay, we are done with the numerical angle made by H2 with the vertical axis. Are these numerical easy? Yes.
सर इजी नाही आहे, थोडंसं कन्फ्युजिंग आहे, बट ठीक आहे, कळलं.
आहे एवढं नाही. ओके ओके टाइप्स.
Okay types. Okay, fine. So these numerical boundary condition numerical were compulsory numerical in 2012 pattern and 2015 pattern. आपके लिए हो सकता है कंपलसरी। कंपलसरी मतलब थ्योरी एग्जाम में ये न्यूमेरिकल पूछा ही जाता है। आता है मतलब आता है। So from unit number 3, students always prefer to prepare these numerical first. They try to solve these numerical first because these numerical are asked for not more, not less than 6 marks. 6 marks से कम ये न्यूमेरिकल पूछे ही नहीं जाते. At least 6 marks, 8 marks, something like that. In older patterns, they were used to ask for even 10 marks with more unknown quantities. ओके, वहाँ पे ज्यादा क्वांटिटीज भी पूछे जाते थे. So give a thought on this numerical, okay, and prepare these numerical pretty much nicely, okay, and these numerical are important one. These numerical are important. And with that say, let us end this presentation and we will go to some different presentation. न्यूमेरिकल, बीएस न्यूमेरिकल कहाँ पे गया? थ्योरी, ओके, मैग्नेटोस्टैटिक्स. Okay. Now somewhere we were discussing about the magnetostatics. So first we had a Biot-Savart's law. Okay, then we had application and we got formulae for the your some special conditions. Okay, we have some sign conventions about the angles. We had some derivation, then we have Ampere's law. Okay, then we have applied Ampere's law to some current carrying sheet. Then we have seen the new derivation for boundary conditions, how we arrived at certain formulae by tinkering with the Gauss law and Ampere's law. Okay, when we are dealing with the dielectric mediums, we use Gauss law in both cases. When we are dealing with the magnetic medium, we use Gauss law as well as Ampere's law. For getting the tangential component, we always use a loop, and to get normal components, we always use a surface, and we have used a cylindrical surface. Okay. Then we also went for a relation between the line integral and surface integral by using the Stokes theorem. The relation between the formula used over here in blue color, current density is nothing but a curl of magnetic field intensity. उसका जो derivation है, if you are interested, you can derivation. तो मैंने वो सिर्फ बता के रखा है. Then we have magnetic flux density. आपको पता है सारी चीजें. B bar is equal to mu 0 H bar. Okay, I want to give some important hints over here. So mu 0 do have some value just like epsilon 0. Okay. जैसे आपका ये था d bar डॉट ds बार इलेक्ट्रिक फ्लक्स डेंसिटी के लिए गॉस लॉ का. ओके, क्या था कि नंबर ऑफ फ्लक्स लाइन क्रॉसिंग द सरफेस एरिया, क्लोज सरफेस एरिया इज नथिंग बट d bar डॉट ds बार. ओके, ऐसे था गॉस लॉ फॉर इलेक्ट्रोस्टैटिक्स, इलेक्ट्रिक फील्ड इंटेंसिटी, इलेक्ट्रिक फ्लक्स डेंसिटी. वैसे ही गॉस लॉ फॉर मैग्नेटिक फ्लक्स डेंसिटी भी सेम ही है. ओके, एंड फॉर दिस वन closed surface integration, okay, this is closed surface integration of b bar dot ds bar is always equal to 0. Why? Because if we put a magnet, okay, with north pole and south pole inside a closed, number of flux lines which are exiting the surface is equal to number of flux lines entering the surface. जितनी बाहर निकलेंगी उतनी ही अंदर आएगी flux lines, magnetic flux lines. So therefore this becomes quantity 0 if we are talking about the closed surface. Okay, so closed surface integration of b bar dot ds bar can be represented as divergence of b bar observed over the volume is equal to 0. Therefore del dot b bar is equal to 0, divergence of b bar. सारी lines मिला के एक दूसरे को कांटेक्ट में आती ही है. Okay, so you do have some analogies, illustrations. I will list those illustrations. ये जो है I, यहाँ पे ये डॉट दिया है. I will highlight that dot with red color. Do you remember that whenever you are going to use reference books like Sadiku and William Haidt, the dot indicates the current is coming outside from the paper. Okay, outside from the paper. तो ऐसे अगर current है, so you can use your right hand rule. Point your thumb which is coming outside the paper and your fingers will give you the direction of the current. Okay, sorry, direction of the magnetic field. So those directions are indicated as magnetic flux lines, and you can see a magnetic needle is also placed over here. Then we do have psi is equal to q. We do have a closed surface and some lines, electric flux lines, are coming outside from that plus q. Okay, those are not once again going back to the closed surface, those are just exiting from the q. So number of flux lines is equal to amount of charge enclosed by the closed surface. This is not the case with the magnets. Okay, so number of flux lines which are entering and exiting the क्या कहते हैं closed surface are equal. Therefore total equivalent, the resultant flux lines will be 0. This is very important thing. Another important thing, monopole do not exist. We always have dipole in magnets. We do have north and south. If you break this one, once again we will have a pair of north south poles. If you go on breaking the magnets, you will always have the dipole. Monopoles do not exist, and that means del dot b bar is equal to 0. This is an example of monopole, only single charge. Okay, since monopole do not exist in magnets, okay, in magnets we have del dot b bar as 0. And few of the theoretical theoretical aspects given over here. I will float these theoretical aspects to you. Okay. For magnetic energy density, you need to have only the formula. That's it. Okay. We had a formula for potential energy in electrostatic field. इसका derivation देखा है. Similarly, we have magnetic energy. Okay. Sorry. In an in a magnetostatic field. In a magnetostatic field. Okay. So WE था, E stands for electrostatics, M for magnetostatic. फ्लक्स डेंसिटी था, यहाँ पे मैग्नेटिक फील्ड डेंसिटी. इलेक्ट्रिक फील्ड इंटेंसिटी था, यहाँ पे मैग्नेटिक फील्ड इंटेंसिटी. ई था, यहाँ पे एच है. रेस्ट ऑफ द थिंग्स आर जस्ट सिंपल एंड स्ट्रेट फॉरवर्ड. ओके, so you don't have the derivation for magnetic energy in a magnetostatic field, but yes, you have remember the formula. Okay, I will end the show and I will stop the recording now. Wait, I have to download the attendance as well. Let us stop recording and